Okay, hello everyone. Factoring quadratics when a does not equal 1. We're going to use the same trinomial that we used in the previous video, and we showed method 1, factoring this trinomial using decomposition. In this video, we're going to use again that same trinomial, 35x squared minus 27x minus 18, and we're going to use a different method. We're going to factor this trinomial using a product and sum concept, similar to the way we use product and sum with decomposition. However, we're going to consider how we expand quadratics. So we're going to combine this product and sum technique with the ideas that are involved with expanding quadratics. So let's begin. Let's consider the factors of ax squared. And we could use 1 times 35, we could use 5 times 7. I think we should use 7 and 5 because we need to always keep this sum in mind. And 35 is a large number, and 1, we might be getting a sum greater than 27 if we use those factors. So 7 and 5 are smaller factors which might help us get to a sum of 27 a bit easier. Certainly if these factors don't work, then we would use the other ones. But we start with one pair. And then we consider the factors of negative 18. Again, we could use 1 and 18, we could use 2 and 9, we could use 3 and 6. I'm going to start with the small pair of 6 and 3, and I'm going to make the 6 negative because one of those two factors needs to be negative so that the product equals negative 18. So we have a product of two factors for ax squared, and we have a product of two factors for negative 18. Next, we need to multiply these. So if we multiply the 7 times the negative 6, and I'll explain why in a second why we're doing that, we get a product of negative 42x. And 5x times 3, we get a product of 15x. And if we take these two products and we add them, will we get a sum of negative 27x? And the answer is yes, we will get a sum of negative 27x. So as a result, we found the factors which lead to products that add to equal negative 27x. And in this technique, that allows us to go straight to our factored form without having to use decomposition. We use the product and sum idea along with products, along with the product and sum of the factors of 35 and negative 18, as well as the product of those factors, 42 and 15, that add up to negative 27x. And we could take them and organize them right into the brackets and create our two binomials. These first two factors go first in each bracket, and these second two factors go second in each bracket. However, we need to consider how they're multiplied. So since 7x has to multiply with the negative 6, that means if we consider how expanding quadratics occurs, that means the 7x, in order to multiply with the negative 6, have to be in different brackets. Because if they're not in different brackets, the 7x will not multiply with the negative 6. And thus, the positive 3 fills in the space in the first bracket, which also allows it to multiply with 5x in different brackets. And this is when we check our write-up if we place them in the correct brackets. So I just erased those arrows. I'll rewrite in our factors of 3 and negative 6. And I'm going to change colors here. And let's review how we expand brackets. 7x times 5x, that'll equal our 35x squared. 7x times negative 6, that'll give us negative 42x. And I might as well write in our 35x squared. Okay. And 3x times 5x will equal 15x. And finally, 3 times negative 6 will be our negative 18. And we already confirmed that these middle two terms add up to negative 27. So what this has allowed us to do is go straight from standard form into factored form with the consideration of our factors of ax squared, which are 7x and 5x, and the consideration of the factors of negative 18, which are negative 6 and 3. And then by multiplying each of those to equal negative 42x and 15, which add up to negative 27x, leaves us with our understanding that the factored form becomes 7x plus 3 and 5x minus 6. That concludes this video on factoring quadratics when a does not equal 1. Thank you for watching and have a great day. You guys are awesome.